Welcome to this video. In this video, we will discuss about properties of addition and subtraction of integers. Let us first discuss closure under addition and see whether this property is true for integers by taking some examples. Before that, let us recall what is an integer. You know that integers form a bigger collection of numbers which contain all numbers and negative numbers. See this number line. Here, -1, -2, -3, etc. 0, 1, 2, 3, etc. are all integers. Now consider the following sums. 10 plus 14. Here 10 is an integer, 14 is an integer, and its sum 24 is also an integer. Consider another sum. -7 plus 4. Here both -7 and 4 are integers. And what about -3? Is it an integer? Yes, it is also an integer. Take one more example. -40 plus 0, which is -40. It is again an integer. You can take some more examples. From these examples, we observe that the sum of two integers is always an integer. That is, addition of integers gives again integers. We say that integers are closed under addition. Generally, we can say that for any two integers a and b, a plus b is an integer. Next, we will discuss closure under subtraction. Here we can see what happens when we subtract an integer from another integer. Observe these examples and see whether the difference is an integer or not. 9 minus 11, which is -2. Here 9 is an integer, 11 is an integer, and its difference -2 is also an integer. Take another example. 15 minus -10, and it is 15 plus 10, which is 25, and 25 is also an integer. Take one more example. 6 minus 6, which is 0. Here 6 and 0 are integers. In all these examples, the difference is also an integer. So we can say that integers are closed under subtraction. Thus, if a and b are integers, a minus b is also an integer. Next, we will go through commutative property. Look the following sums. We have 5 plus -2 equal to 3. If we change the order of addition, it will become -2 plus 5, which is again 3. So we can say that 5 plus -2 equal to -2 plus 5. See one more example. -14 plus -6, which is -20. If we change the order of addition, it will become -6 plus -14, which is again -20. So here also -14 plus -6 equal to -6 plus -14. Try this with some other pairs of integers. We cannot find any pair of integers for which the sums are different when the order is changed. That is, for any two integers a and b, we have a plus b equal to b plus a. That is, addition is commutative for integers. Now we will look whether subtraction is commutative for integers. Consider these examples. We know that 5 minus -3, which is 5 plus 3, and it is 8. If we change the order, it will become -3 minus 5, and it is -8. So it is clear that 5 minus -3 not equal to -3 minus 5. We can check this by taking other examples also. So we can say that subtraction is not commutative for integers. Next comes associative property. Consider the integers -5, -3 and -2 and look at -5 plus -3 plus -2, which is -5 plus -5 and it is -10, and -5 plus -3 plus -2, which is -8 plus -2, again -10. In the first sum, -3 and -2 are grouped together, and in the second, -5 and -3 are grouped together. In both the cases, we get the same result. So we can say that -5 plus -3 plus -2 is same as -5 plus -3 plus -2. Similarly, we can check the result by taking more examples. We will not find any example for which the sums are different. That is, for any integers a, b and c, we can say that a plus b plus c equal to a plus b plus c. That is, addition is associative for integers. Next property, additive identity. Look these sums. -4 plus 0, which is -4, -5 plus 0, -5, 0 plus 6, 6, 0 plus -18, -18. In all these examples, when we add 0 to any integer, we get the same integer. So 0 is the additive identity for integers. Generally, we can say that for any integer a plus 0 equal to a equal to 0 plus a. Now, using these properties, try to fill up the following blanks of questions and check your answers with these answers. Please like, share and subscribe for more videos. Thank you.